You sit down to watch a movie, but the remote has 50 identical little rubber buttons, and pressing the wrong one switches the input to a snowy screen, unexpected item in the bagging area. Compare that tension to looking at your phone to unlock it, or effortlessly swiping up to see the next video. Zero friction, zero confusion. That difference comes down to a specific field of study called human-computer interaction, or HCI. It's the science of making technology easy, understandable, and human-friendly. When design ignores how people actually behave, we end up blaming ourselves and feeling foolish. When the design aligns with our natural instincts, the machine disappears, leaving only our intent. Designers categorize these moments of failure into specific gaps. The first is the gulf of execution. This happens when you know exactly what you want to do, but the interface hides the steps to pull it off. Think of a hotel shower with 3 unmarked dials and a pull tab. You want hot water, but the controls give you absolutely no clue how to get it. Then there is the opposite problem, the gulf of evaluation. Here, you manage to figure out the controls and perform the action, but the system refuses to tell you if it actually worked. You click upload on a massive file, and the screen just sits there. No progress bar, no spinning wheel, no confirmation message. You're left guessing if it's processing or completely frozen. Drop users into either of these gulfs for more than a few seconds, and they will close the app, walk away, and find a competitor. To keep people out of those gulfs, we have to look at interaction. It is a continuous communication loop between a human command and a machine's feedback. The most familiar loop is explicit interaction. You tap a screen, type a message, or give a direct verbal command to a smart speaker sitting on your counter. But systems are increasingly using implicit interaction. You don't press a button. Instead, the software monitors your behavior and reacts automatically. It adjusts your screen brightness in a dark room or queues up a movie based on your watch history. Modern devices blend these methods into multimodal interaction. You glance at your phone to unlock it via face recognition, dictate a text message, and swipe away a notification all at once. The burden of communication is rapidly shifting. Instead of forcing you to learn complex commands, the device interprets your natural behavior, lowering the mental effort required to use it. Without explicit instructions, designers guide your behavior using a visual vocabulary. The strongest element is an affordance, a physical or digital shape that suggests its use. A raised button begs to be pushed. Designers layer signifiers on top to clarify the action. A drop shadow confirms it's clickable, while a glowing arrow points to what will happen. This vocabulary tries to align 2 different realities. The engineer builds the system with a specific conceptual model of how the code runs, but you, the user, approach it with a mental model, a guess at how it works based on past experience. Look at early consumer microwaves. The engineers understood the precise wattage and timing controls, but the everyday cook just wanted hot food. Trying to decipher the panel led to people simply hitting the plus 30 seconds button over and over. When the screen matches the user's mental model perfectly, friction vanishes, and the learning curve drops to 0. Building that frictionless environment requires strict usability rules that act as a psychological safety net. Good systems plan for your mistakes through the reversal of actions. When you accidentally hit reply all on a sensitive email, the service provides a brief 5-second window to hit undo and save your job. They also reduce your overall memory load. A browser handles the heavy lifting by automatically filling in complex, randomized passwords, so you don't have to keep them in your head. Delivery apps provide informative feedback to soothe anxiety, showing a live map where a tiny car creeps down your exact street. These usability rules are vital structural elements that prevent human error before it occurs. Getting the mechanics right gives a product utility and usability, but user experience, or UX, measures the emotional reaction. You can drive a high-performance sports car that vibrates, is hard to park, and has a confusing dashboard. The usability might be terrible, but the sheer thrill of the engine delivers a fantastic experience. Combine high usability with an emotional peak, and you redefine expectations. When the 2007 iPhone removed the physical keyboard in favor of smooth, gesture-based animations, suddenly scrolling through contacts felt satisfying. A perfectly optimized experience solves the mechanical problem while simultaneously engineering trust and emotional attachment to the brand. But that deep knowledge of human psychology can be weaponized. Designers can use what they know about friction to trap you, a practice known as dark patterns. Interfaces will use fake countdown timers to induce panic buying, bury the unsubscribe button under layers of confusing text, or trap you in an endless scroll that actively bypasses your brain's stopping cues. As we move towards spatial computing and AI, interfaces are leaping off our screens and into our physical environments. The ethical stakes of how machines interpret our actions are multiplying. Future technology must prioritize empathetic design that serves human intention rather than exploiting human attention.